What we're going to look at in this tutorial is the ambiguous case in trigonometry. And the first thing I want to talk about is when the ambiguous case applies. The only time ambiguous case is going to be an issue is when the information given to us is in the form side angle. So if you take a look on the left-hand side here, if we are given, in this case, angle A, and side C, this falls into the side angle case. So you have to have an angle and its opposite leg in order to kind of fall into that side angle. So let's say hypothetically this was side B. Well, then it's no longer ambiguous case. So if I have an angle, its opposite side, and then some other side, that's falling into the ambiguous case scenario. Now, so I have this visual here, and then off to the upper right-hand side, I have the two things that we're going to really be focused on here: the sine of the given angle and the ratio of the legs. Now, what I want to talk about is why this ratio is important and how we need to set it up. We're going to be comparing how this ratio of the legs compares with the sine of the given angle. The way you set up this ratio is extremely important. In this particular case, I need to put side A on top, because when we're doing sine is always opposite leg on top over, and usually we hear it as the hypotenuse, but in this case it's not technically a hypotenuse, but I want to make sure that the opposite leg of the angle is on top. So let's say I was given angle B, then I would need leg B to be on top of my ratio. So what I want you to do is keep a close eye on these two numbers over here, and we're going to walk through each of the four scenarios. And that's what can make this a little difficult, is we have four scenarios. It's not just one situation. I got to pick out which one of the four it is. So the first one I want to take a look at is if we have a small leg. So if I were to start adjusting this red leg here, but I'm keeping it smaller than all the way down here, if I'm keeping it kind of a short leg here, notice how if I put it right here, that's not a triangle. It's not big enough. Or if I bring it down here, still it's not big enough. I haven't created a triangle until I've extended it to that blue horizontal line. And what I want you to do is I want you to focus on these numbers on the upper right-hand side. Notice how if I have that short leg, that blue number is not going above the sine of A. It's always staying below, in this case, that 0.64. So that creates scenario one. When I have a situation where the ratio of the legs is smaller than the sine of the angle, I have zero triangles possible. I cannot create a triangle in that case because that leg, that A leg, is not big enough. So that's scenario one. When the ratio of the legs is smaller than the sine of the angle, I cannot create any triangles. Take a look at scenario two. Now, let's say that I extend that red line just enough so that it touches the blue horizontal line. Now take a look. I have a perfect match. That creates scenario two. When the ratio of the legs equals the sine of the given angle, that creates one right triangle. So I only have one triangle in that scenario. Now let's extend that red leg just a little bit past the blue. So let's bring it to like right about here. Now take a look. I could either connect that red leg on the outside to create one triangle, but if you take a look over here, I could also extend it to the inside. So I have two possibilities, either one or two. One or two. Take a look at the ratio. Now my blue, my ratio of the legs, has gone above the sine of the given angle. So as long as I'm kind of just past the blue horizontal, I'm creating two. I can either connect on the outside or the inside. So that is scenario three. When the ratio of the legs is now larger than the sine of the given angle. Now take a look. It also says it has to be less than one. Let me explain why. If I were to take that red leg and make it really large, now notice how I've extended it so far that it's no longer connecting on the inside. Now it's only connecting on the outside. See, I don't have a connection over here on the left. So now I can only bring it out to the far right side. And when that happens, notice that my ratio, my blue ratio, has now gone past 1. Now I've extended it beyond a number of 1. So once I go past 1, let me bring it in real close. Take a look. Look at that blue 1.08. See how it's getting closer, 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 closer? The moment I get it bigger than 1, I'm no longer connecting on the inside. If I go just inside 1, I have a connection on the inside. I also have a connection on the outside. But the moment I bring it past 1, it's kind of disconnected on the left now. Now I can only connect it on the right. So that creates scenario 4. When we extend that ratio beyond 1, once it's bigger than 1, I can only create one triangle. And it's going to be way on the outside there. So those are your 4 scenarios, and they're all dependent on how that ratio compares to the sine of the given angle. So let's go through them again. When A is too short, when the ratio is smaller than the sine, no triangle is possible. When it's a perfect match, it's one right triangle. When the ratio of the legs is bigger than the sine but less than 1, I can connect it in 2 places, 1, 2. But once I extend that ratio beyond 1, now I can only connect it in 1 place. So those are your 4 scenarios for the ambiguous case. I hope that helped you. Remember, always compare the sine of the given angle and the ratio of the legs. Good luck.